Hi guys! Today we are going to talk about the build of the Odyssey, and as I promised you in the last video, comparison of the size of these two. The Avanti that is flying great, and this is the Odyssey from Top Model RC. It's much bigger, it's taking all my workshop, so this is gonna be a fun video. I will tell you a lot about the setup that I prepared, the cool ideas that I thought about to install in this jet, and I hope it will be nice. And also today is my father's 80th birthday, and he's super fit, super happy, and he tells me every day that every day he's more happy than the previous one. So I wish you all this, and the Christmas is coming, so I wish to all of you happiness and good life and smile on your face. Okay, so let's get on with the Odyssey. I have to disassemble it and put it on the table because it's just too big. It doesn't fit on the table. Okay, so while disassembling this plane, I'll tell you a few words about the airframe. I had few full fiberglass jets before, and some of them were average quality, some of them really good quality, and I must say that this one is a good quality. I heard some bad reviews about these planes, but it was a few years ago when they just came to the market in 2017, but now we have 2020, end of 2020, and I think they worked on it, because I looked around and I checked all the fuselage, all the wings, everything, and everything is nice. Everything is glued properly. The inside frames don't stick out from the fuselage. The paint job is nice. All the locks work nice. Everything fits, and fit and finish is nice. Yeah, everything is good. So, and also interesting information is that this is a 2.3 meter jet, which is large, and the airframe weighs 7 kilograms, which is not much for this huge jet, because the airframe of Black Horse Viper, which was 1.9 meters, and this is balsa, the Black Horse Viper is balsa, so it's supposed to be very light, and it is, was 5 kilograms. So considering the size difference and the technology, this jet is super light. So I'm very, very pleased. Of course, there will be jets lighter than this on the market with this size, but bear in mind that this one costs 1,300 euros, so the airframe, so it's super cheap. It doesn't cost 3,000 or 4,000 euro, which should, with this size of jet. So I hope it flies well. Everybody says that it flies well, but I think it's worth the money. Okay, so we are disassembling. It's very easy, just unscrewing 2 screws here, 2 screws here, some screws here, and this comes out super easy and super nice. And the spar is huge. I will change it from aluminum to carbon. It will be costly, but I'm not sure. We'll see. If I get my hands on the cheap carbon one, then I will do it. You have, it's called, I think, live hinges everywhere, which is nice, but we'll come back to this in a moment. And the wing weighs 1 kilogram, and it's huge. And the wing of Black Horse Viper, balsa wing, was also 1 kilogram. The difference was 30 grams, so it's almost nothing. And here the edge is very sharp. Everything is great, and the profile is symmetric. That means that the plane will be very fast, because the top speed of the plane is very much dependent on the sharpness of the leading edge, which is quite sharp here. Sharpness of the trailing edge, and lack of gaps, which is really nice here, because we have, I think, a millimeter gap here and less than millimeter here. Of course, when you're flying level, there are no gaps on the control surfaces because there are no gaps. And also, the top speed is dependent on the profile. If you have asymmetric profile, the faster you go, the more lift you generate. And then you have to fight with the lift, creating, like pushing the elevator stick forward, so this plane goes down. But you're not losing this lift. You have to consume it somehow. And when you have a symmetric profile, you're not generating more speed, more lift increasing speed, which means this jet will be fast, even though it's big. So it's a very good news. symmetric profiles. Okay. Okay, so further disassembly. It's super fast, so it's gonna be very easy to take it to the field. A huge spar. Okay, the tail wings also go out nice and smooth. Of course, symmetric profiles and very sharp. The percentage of the thickness to the length, it's very small, so it means that this is a very fast airfoil and very sharp leading edge, which promises very good flying characteristic. It will be, when you have a sharp leading edge, the plane is not that good for stalling because it might stall, but with these huge wings and low weight, this plane can fly with almost no speed. So, but the top speed will be great because the leading edge is very sharp. So it's nice. Okay, one more tail wing horizontal. It's called the horizontal stabilizer. Yeah. Aluminium spar, which I will change for carbon for sure because I think it's 12 millimeters. I have them plenty. So, and the last thing, and this is the only hinge that is on plastic hinges, but it has to be. And besides that, it's really cool. Okay. All right. So yeah, we will open the cabin. It needs some painting here, so it's nicer finished. But it's every jet comes like this, so it's, and it comes in standard a beautiful cockpit. Just missing the pilot, but this cockpit is really detailed. It's really nice. And it's light, very nice. So if somebody is for scale flying, this is cool thing. And a lot of space for batteries and electronics. And here a hatch for a jet, because this is a turbine jet. Originally it is designed for a turbine. It comes with tanks and fuel tanks and the shubrura in the tailpipe. For I think 14 kilo turbine, but I'm giving this to my friend, which is flying turbines, and we are going to set it up for EDF. And now we talk about that. We talk about this. All right. So, if you hear the printer, 3D printer in the background, it's because I'm just printing a new shroud, EDF shroud for this jet. Because I've printed already one, because originally I was planning to use this motor. This is a TP half a kilo motor, 40 millimeter motor, TP power, but I decided that this is a little bit too weak and a little bit too high kV, because 1100, and on 12S it will generate too much current. So I purchased a HET motor, which is 39 millimeters, and I'm printing a 39 millimeters shroud for EDF for this motor. This is 600 grams, 935 kV HET motor, which I love, with 8 millimeter shaft. This motor can generate 10 kilowatts easy, and it doesn't burn. It will be warm, but it will be not hot, and it's very cool because, of course, this motor will be with the heatsink, which goes up with the glue. But it's nice here because this shroud has a nice lip, nice intake, and this design is like reversed. I designed a lot of EDFs like that, and it works super nice. The motor slides in, the rotor goes here. The rotor goes here on the shaft. Of course, we just put it just like that. And then we have a stator, which straightens, it's not cleaned yet, it's just straight from the printer, which cleans the airflow, like this. Okay, Okay, it comes up like, no, it comes up like this, yeah. And I designed it in a way that the rotor is far enough from the stator blades so it doesn't create this sound of hitting, this sound of whining, because if the rotor is too close to the stator, you hear this beep, and you can avoid it by increasing distance between the rotor and the stator. And of course here will be a cone to have a nice smooth airflow, and a tube that goes all the way to the back of the plane. And this rotor is also far enough from these blades that are holding the motor in place. And everything is designed for perfect finish. So if any one of you is thinking about using JP rotor 120 counterclockwise with either 40 millimeters or 39 millimeters motor, 120 size, then I can provide you with free STL file to print it yourself. This must be ABS or ASA. This is ASA, it's much stronger than ABS, ASA plastic. And you can create your own, it's 3 pieces, 1, 2 and the cone, 3. Create your own 120 EDF for this rotor with your own choice of motors, but from this companies. And I promise you this will be super quiet. You will not hear this, it will be whoosh only, and it's very efficient because it's all designed to be efficient. Also the number of stator blades is 11 because the rotor is 12, so you have the least possibility, the most random possibility of hitting the air to the blades, because this is like this. If you have 12 it will be bam bam bam. If you have 11 it goes per 1 hit per 1 rotation. It's very nice. Okay, so this is cool. I actually experienced, oh maybe here. Okay, it's not a commercial, Turbines RC, but I got this stuff from Turbines RC, which is a European shop, which is amazing with their service. You buy a product on Monday and on Tuesday it's at your place in Europe. It's amazing. I think worldwide also, not one day but maybe 2, 3, I don't know. Super fast. So I recommend this shop to you. It's nice working with them. And I flew a lot on Vemotech MIDI Evo. They have 80 millimeters, 90 millimeters and 100 millimeters, and this is 100 JP. And what I noticed is that Vemotech is quieter than JP. It has 11 blades, JP has 12 blades. What is the reason the Vemotech is quieter and it's more jet-like sound? Because Vemotech is nylon reinforced with fiberglass, and it doesn't create this electric sound. It's like metallic sound, this one. And this one is super hard aluminium and it does create this metallic sound. So when you fly you constantly hear this, and it's very hard to get rid of it. But this one, it doesn't. This one just makes and the efficiency, yeah. This one is like this and this one is like this. And the efficiency of this one is amazing. This is super efficient rotor, the EDF rotor from Vemotech is very nice because the blades are super thin. The other brands, I checked them, I like this, tested them all. Their blades are very thick and fat, and when the blade is fat, it creates a lot of drag. And these blades are super slim, and that's why it's so efficient. So I recommend to, and this one costs really like 1/3 of the price of this one. So it's really, I'm not sure, but I think so. It's much cheaper. So I think up to 6 kilowatts, a very reasonable choice is a Vemotech. If you're using up to 6 kilowatts setup on your planes. If you are using higher than 6 kilowatts, like for this jet I'm preparing 10 kilowatts, then maybe the aluminum rotor is better idea, because this one, I don't know, it might break, so I don't know. But just the information. So this one, lovely up to 6 kilowatts, but important that you have to use a very big motor, big enough not to overpower your motor, because when the motor gets super hot, this is plastic and it gets kind of loose, and of course you will lose balance. But if you have a proper motor designed for this power, then it will work wonders. Like the EDF that I was using. This is a 100 EDF from Vemotech, a whole set that I was using on Black Horse Viper, and it was generating up to 5 kilowatts. Super smooth, super quiet, super nice, super. I made maybe, I don't know, 30 flights on it. It doesn't show anywhere, nothing, and it's super nice. Okay, so this is it. Important information. Okay. Some of you guys were asking me about non-rotor usage of this JP fan. I prepared the lip with the non-rotor, lip with the cone that is not rotating, and this one was actually inside the Avanti that was flying on 12S, and then I had a crash on it on 12S 8 kilowatts, so this was the 8 kilowatt setup. It was flying nice, everything was great, the motor didn't burn, everything was super nice, only the ESC gave up. And when we talk about the ESC, this is the ESC I was flying on with this 8 kilowatt setup. This is a Sunrise Model 100 amp 12S ESC. It's a BL Heli firmware on it, so you have to set it up on your computer. And it holds up to 150 amps. Such a small thing. It's so small and so light, it's maybe 60 grams. It's super small. And on 12S, I am flying on it up to 150 amps, no problems. But this setup was 200 amps and the middle lead just came off. Okay, so these are the two brand new ones. I just set them up and program them and check them if everything is okay. And for this big jet I make a nice test. First I will test it on the ground for sure. I am removing the MOSFET board out from the controller board, from the board that is underneath. I'm soldering it out. It comes out with the leads, with the battery leads, motor leads, and with capacitors. And I will solder this board in to the pins of the first MOSFET transistor board. So it will look like this. And I will glue on the top a big radiator, one big radiator, and I will connect the leads together here. It goes like this, here and here, and battery cables will be also connected by like a wide joint, and it will be two MOSFET boards on one controller board, so theoretically it will be 300 amps 12S for a very low price, because these ESCs are very cheap. They're 80 euro or 70 euro, very cheap. Like for this performance, it's amazing. And I did this test before and it worked on other models. So I hope this one, I have to solder it really perfectly. I hope this one will work too. And this is very interesting, because if it does, then I can push it to 200, 250 amps if I decide. And what I checked also, that this ESC easily handles 14S, and I also tried it on 16S. So it's really there is a room for some testing. So I'm very excited to check it out. Okay, so now just to come back to this jet for a second, because we were talking about the electronics, but I want to say a few words about this. The setup of this big EDF to this turbine jet I had to modify the brackets here, because the normal turbine engine is smaller, is more narrow, so it was not enough space. But I took the Dremel tool and very quickly I just sanded this little bit, and now is enough space to drop this. It's like, this is 17 centimeters wide, the lip is 17 centimeters wide. You just drop it in, screw with 4 screws on each side, and it's perfect. Then the tube goes back, the motor sticks out here, the ESC will be here, and the battery is just in front. And very important thing for guys that want to convert turbine jet into EDF jet is the intake of the air, because turbines, they need way smaller area of the intake of the air than the EDFs, and that's why you have to clear all the obstacles on the way to the EDF. And here the jet came originally with the intake tubes coming here, the diameter I think 100 or 120, so very small. And I took Dremel again and I just cut it out. It's directing the airflow from the intakes just towards the EDF to avoid this framing. But now it's totally open. This is totally open. And one more thing in the front of the plane, I removed, which is also important, I removed totally, oh by the way, this is the tape I glued just not to scratch the paint of the plane. I will remove it when I finished working. I removed the door, which comes very nicely with the hinges and everything. I removed it because these doors, they actually don't slow down the plane so much. Actually, lack of these doors, they don't slow the plane at all. But you need extra airflow, extra intake of the air for EDF, so the EDF is not suffocating. And also this air is used for cooling the batteries, because the batteries are loaded and they get hot, every battery. And LiPo and the Lion, I will be flying on Lions, and you need this intake. So this will stay open and the airflow will go here around the batteries to the EDF. So this is important. And if any one of you thinks, wow, this is a big jet, how to transport it to the field, it's not so bad. This jet has here in the front 6 screws that you can screw them in with your hand. Super easy. Of course, you need to tighten them with the Allen key hex, and it comes up like this. And you can actually set it up with the one connector or with a few connectors. So you disassemble it, and then the plane becomes quite small, and you can transport it in a normal car. And it really takes a minute to separate the nose from the fuselage. Super nice. I really like it. Okay, so nose goes away. I'm not sure yet if I will, in the beginning, if I will use the cockpit or if I will paint it with the, like I did with Avanti, with the black plastic dip spray on rubber, so it looks sports, like a cool sport jet fuselage, the canopy. And then if I want to go back, I can always peel it off, because this is good. This is cool about this spray on rubber, that it's, if you put a lot of layers and it's thick enough, you can easily peel it off. The general idea of this jet, for me, is not to go into expenses, because this is not a 4,000 euro jet, it's a cheaper jet. So I decided to use also cheaper components and decided to try to create a reliable jet that is not super expensive, that we don't have to spend 10,000 euro on. So that's why I've chose components that are not expensive, but the ones that I tried and the ones that I am confident with, and I flew before. That's why the ESCs are so cheap. And for example, the servo. This is a servo that generates 14 kilograms on 6 volts. I will fly on 7.4 volts because it can operate up to 7.4, and it will generate probably around 18 kilos. I tried on 6 volts, I tried to stall it with my hand. It's impossible. It's so strong. It's so strong you cannot believe. And this servo, I know this brand very well because I flew a lot of them on the Viper jet, on all of my other planes. This servo is a 10 euro TOPRC servo Metal Gear 946R. It weighs I think 50 grams or something. Very strong Metal Gear servo with bearings, with everything. And normally I would use a lighter servo probably around 10 kilos or even less, 8 kilos for this plane, because this plane will be flying at around 12, maximum 14 kilograms. It depends on the battery setup. But because the reason I used much stronger servos is that I want to do something which I did some time ago on my JTM Viper jet, which is also a full fiberglass jet. I want to resign from the servo horns here sticking out from the control surfaces, from flaps and all the control surfaces, and I want to install the servo inside the servo bay and connect the control horns here. Some of the brands, they do it already, like Carf models, I think they use it on flaps, or some other brands. And I did it on all control surfaces, including the rudder, so no servo was sticking out, disturbing the airflow, and it will be totally hidden in. And that's why I use these super strong servos, because there will be enough torque to operate flaps and ailerons and everything. And this way I will have completely clean airflow around the wings and the whole fuselage. And this might actually give me even 20 kilometers of top speed, so, or even more, because the drag increases so much with when the speed increases that it's unbelievable. And if I did a normal servo connection, I would for sure print on the 3D printer the covers for the servo horns and the rods to improve the airflow. But because I don't do it, the wing will be clean. So this is super nice. And also, going into the inexpensive way of setting it up, the expensive landing gear set costs 1,000 euro at Big Planes Netherlands. The cheap one that comes with the plane, that you can buy with the plane from Top Model RC, costs 600 something euro. But it's still a substantial sum of money. It's almost like another plane. But I'm going to use this landing gear mechanics, which I used many times before. This is 30 euro mechanics. You can buy them on Hobby King. They sell them all around the world. I use them a lot. They flew also on my Viper jet, 2-meter Viper jet from Black Horse, and they are super reliable and super strong. And they will fit perfectly here. And these are strong aluminum ones, very nice. And they don't require a sequencer, because they are just connected directly to the receiver or the hub. And I will use as a landing gear my old trusted landing gear from some other old Black Horse model, which is nice. Only one thing, I'm changing the spring for a much stronger one, and I changed the wheels. I printed those wheels on my 3D printer from a very nice rubber, and I put the bearings on them, so they're very strong. And it will fit perfectly. Here it will be a 3D printed nice cover, so it will be, actually the cover comes with the plane. So it will be super smooth and no air disturbances, so it's gonna be cool. And the whole set will cost me, this I had, but you can buy them cheap, and this is 90 euro, so I saved 600 euro. Just to give you an idea, this is a 6S 4000 Lion that I'm flying on. It's 400 something grams, and I will fly on this jet on 6 of those or 8 of those, but most probably 8 of those. So it will be 3 something kilograms of battery weight. But just to give you an idea, this is very nice battery. Okay, as you know, I'm flying on a FrSky system, which is super nice, with OpenTX firmware inside. It's a dream. I fly on OpenTX already many years, and I don't imagine flying on anything else. It's just open. It's very open. It's very nice. And FrSky just came out with a new hub. It's a new redundancy box, because they had some other boxes previously in previous years, but this box is super nice because it has so many holes for servo connectors, and every hole of the servo connector has like overload fuse which is super nice, and it gives a telemetry information that this channel was overloaded. So I'm going to connect every single servo, every single landing gear servo, every single LED connection to this power box. This is not a power box, this is a redundancy box. It's called the redundancy box 30, I think, because maybe it has 30 connections. But, which is nice and super nice. It costs 170 euro, I think, or 150 euro. It's super cheap. But what is really nice, you connect two batteries on XT30 connectors up to 6S. There is a built-in BEC circuit, but not one, two BEC circuits inside, giving out up to, I think, 15 amps on each BEC. What is interesting, top 8 channels, this is 1, 2, 3, 4, 8, I think it goes like this, it doesn't matter, is with full telemetry. So it gives the voltage, the amperage, the total consumption, the whole history of the load of the first 8 channels. The rest of the channels is just equipped with the fuse and information that it was overloaded. So this is super cool. Also, you load in the SD card, which acts like a black box, which records all the flight data, and in case of crash, you have information what caused the crash, which is super nice. Here you have the two XT30 connectors for, I don't know if you are using turbine for running a turbine or something else, high load application. And which is super cool, which I like, I think the most about this redundancy box is that this is with built-in gyro, which means that my jet will be flying with stabilization already inside this for 150 euro. This is mind-blowing. So, and this of course works perfectly with my FrSky radio, but this works with every radio. It doesn't matter what radio you have. So it's super, super cool. And of course, a nice thing is that you have a magnetic key. So if you're flying a turbine, you don't need to open your jet. You just put the magnetic key and it switches off. So, or switches on. So, which is very nice. Of course, there is many more, and you set it up with the radio or with the computer. There's many more features about this, but I just didn't read about them all. And you have not 2 redundancy receiver connectors, but 3. So I will be using 3 full range receivers from FrSky, and this is already a new range of receivers running on this new protocol access. And this is a receiver. It's a full range 2-kilometer receiver from FrSky with telemetry, with S-Bus, with everything. And I'm connecting 3 like that around the plane, and they cost I think 17 euro each. It's unbelievable. And of course I will connect via smart port all my sensors that I use in other jets, so it will be power from the motor, voltage, GPS, pitot tube, everything, and the variometer, temperature gauges, everything. So this is just super nice. And of course the price of the FrSky system is very low, and the system is very reliable because I flew on them already for years. Ta-da! Just to wrap it up, we were talking a lot. Just to wrap the video up, I just show you the batteries that I'm flying on. The Lions Samsung 40T, 4000, probably you know all of it. This is 8S, so if any one of you needs brackets for 8S, just drop me an email. Very, very nice setup. This is 6S that I fly the most, it's the most convenient for me. This is 4S, so small, and 3S, 4000. It weighs 230 grams, something like this, with cables, with everything. So, I like these batteries. I'm not coming back to LiPos, unless, which my brother, which is standing behind the camera, is pushing me for, unless we will reinitiate the project of FunJet Ultra, which would be now, because I have the motor in the shelf, in the drawer, which would be on 12S 150, 160 amps on the 80mm rotor, and it will be not exceeding, but I think around 500 kilometers per hour EDF. And then I would need, I wouldn't fly on Lions, I would need, I think the best would be the Graphens from Hobby King, because they are the stiffest, they give the most current in the size. The current is not the capacity, the current, and for top speed braking you need current. So this probably would be it. And I forgot one more thing. EDF. You can fly on a small EDF in the bigger jet and a big EDF on the bigger jet. The only thing is that the small EDF, to create the same power load, needs to push the air with higher speeds. So then the effect of the drive is more like a gas turbine, because the air travels very fast, but there is less volume of the air. And then if you use a bigger EDF like 120, there is more volume of the air, so that the static thrust is higher, but the speed of the air is lower. So if you're looking for a fast jet, always aim for the smaller rotor. If you're looking for the jet that takes off nicely and has a very nice vertical forever, then go for a bigger rotor. That's why it's not really that important if you use a big rotor or a small rotor, but you need to know what you're aiming for. Okay, thanks a lot. I hope you enjoyed it. It was a lot of talking. I hope next time you will see the Odyssey maybe flying, we'll see. Alright, thank you so much and see you soon.